everyone, I am Ms.S.AANANTHI, Assistant Professor at Department of B.VOC Marine Food Processing and Preservation Technology, A.D.M. College for Women, Autonomous at Nagapattinam. Today my topic is Composition and Nutrition in Fish. Introduction to Fisheries. Fisheries is an economic activity that involves harvesting fish or any aquatic organism from the wild or capture fisheries or raising them in confinement, culture fisheries or aquaculture. It may be traditional small-scale fisheries for sustenance or large-scale or commercial fisheries for profit. Next, fish. Fish is a cold-blooded aquatic organism that breathes with gills and swims with fins. They are categorized as fine fish and shellfish. Fine fish. Fine fish are cold-blooded aquatic vertebrates that have gills, fin with rays and scales covering the whole body. Shellfish. Shellfish are cold-blooded aquatic invertebrates that have various types of locomotory organs and a shell or exoskeleton covering the whole body. They include crustacean and mollusk. Next, classification of fish. Fish is divided in two types, fine fish or shellfish. Fine fish is separated in two types, fresh H2O. H2O means water. Fresh H2O, salt H2O. Fresh H2O divided in two types, lean, fatty. Salt H2O divided in two types, lean, fatty. Next, shellfish. Shellfish is divided in crustacean, mollusk. Crustaceans included crab, crayfish, lobster, shrimp. Next, mollusk. Three types, bivalve, univalve, cephalopod. Bivalve, clam, mussel, oyster, scallop. Univalve included apollon, conch, snail. Cephalopod included octopus, squid. This is a classification of fish. Next, composition and nutritive value. Commonly consumed fish are carp, rogu, sardine, mackerel, pomfret, sea fish, prawns, ribbon fish, sole, Bombay duck, catfish and crab. Next, the composition of fish varies. Fish are not good source of energy because they are not good source of carbohydrate and fat. Next, nutritive value of fish in per 100 gram. Food item, pamphlet black. This is another name is vavalu. Energy is 111 kilocalorie, 20.3 gram of protein, 2.6 gram of fat, 286 milligram of calcium, 2.3 gram of iron. Next, prawn. Prawn is another called yara, 89 kilocalorie energy, 19.1 gram of protein, 1 gram of fat, 323 milligram of calcium, 5.3 milligram of iron. Next, sardine. This is called mati fish, 101 kilocalorie of energy, 21 gram of protein, 1.9 gram of fat, 90 milligram of calcium, 2.5 milligram of iron. Next, seal. This is another name, Vanjaram fish, 126 kilocalorie of energy, 22.5 gram of protein, 4 gram of fat, 71 milligram of calcium, 5.4 milligram of iron. Next, carbohydrate. The shellfish less fat and more carbohydrate than fine fish. Like meat, fish contains some glycogen in muscle tissue. In the live fish, glycogen is the source of stored energy. Oysters are notable for their high content of glycogen. Next, protein. Fish is an excellent source of protein due to its quantity and quality. They contain around 20% this protein. The biological value of fish protein is 80%. Next, fish is rich in lysine and methionine, hence it has supplementary value with cereals and pulses. Next, essential amino acids is divided in multiple types. This is arginine, valine, histidine, isoleucine, leucine, lysine, methionine, tryptophan, tryptophan, phenylalanine. Protein level is an aquaculture feed generally average 18 to 20% of marine shrimp, 28 to 32% for catfish, 32 to 38% for tilapia, 25 to 30% in Indian major carps under ideal bond condition. Next, fat. Fish contains less amount of fat compared to meat and poultry. Freshwater fish contain eicosapentaenoic acid. This is called EPA, and docosahexaenoic acid. This is called the THA. which are omega-3 polyunsaturated fatty acids. Next, minerals. Fish is rich in calcium, particularly small fish when eaten with bones. Marine fish are good source of iodine, selenium and fluoride. Next, selenium is a powerful antioxidant. Oysters are good source of copper and iron. Sodium content of freshwater fish is slightly less than meat. Shell fishes such as oysters are nature's richest source of zinc. The bioavailability of iron and zinc is higher in fish than plant. Next, fish can absorb a number of minerals directly from the water: calcium, magnesium, sodium, potassium, iron, zinc, copper and selenium. This reduces the mineral requirement in the diet. Macrominerals are present in the body in relatively large quantities. The macrominerals included calcium, chlorine, magnesium, phosphorus, potassium, sodium. Next, this is function. Calcium and phosphorus are more directly involved in the development of growth and skeleton, and they act in several other biochemical reactions. Fish absorb calcium directly from the water by gills and skin. The requirement for calcium is determined by the water chemistry. Next, phosphorus function is more critical. Phosphorus is derived from the dietary phosphate. Phosphorus deficiency signs include poor growth, reduced feed efficiency and bone deformities. The availability of phosphorus in feedstuffs varies widely. Next, magnesium function with many enzymes as a cofactor. The dietary requirement can be met from either a water or the feed. Deficiency of magnesium causes anorexia, reduced growth, lethargy, vertebrate deformity, cell degeneration and convulsions. Sodium, potassium and chlorine are electrolytes. Sodium or chlorine resides in the fluid outside the cells. Potassium resides inside the cells on intracellular cache. Because of the abundance of the elements in the environment, deficiency signs are difficult to produce. Microminerals are present in very small amount of bodies in fish, but they are important in fish health. Next, the microminerals included the copper, iodine, zinc, manganese, selenium. Next, this is function. Copper is a part of many enzymes and it is required for the activity, although it is necessary for the fish. Copper can be toxic at concentrations for 0.8 to 1 milligram per liter of water. Fish are more tolerant of copper in feed the water. Next, iodine is necessary for the formation and hormones from the thyroid gland. This can obtain iodine from either water or feed. Similar to land animals, a deficiency causes the thyroid gland to grow. Conditions similar are goiter. Iron is necessary for the formation of heme compounds. These compounds carry oxygen because natural waters are low in iron. Feed is considered the major source of iron. Iron deficiency causes anemia. At higher level, iron can be toxic and causes reduced growth, diarrhea, liver damage and death. Manganese function as a part of enzymes or as a cofactor. Although it can be absorbed from the water, it is more efficiently absorbed from the feed. A deficiency causes reduced growth and skeletal abnormalities. Next, vitamins. Seafood contains significant amount of vitamin B12, especially shellfishes. Fish liver oils are excellent source of fat-soluble vitamins. Shark liver oil contains 10,000 to 24,000 IU vitamin A per gram of oil. Rohu contains vitamin C. Fish are good source of niacin and vitamin D. Seafoods contain significant amounts of vitamin B12, especially shellfishes. Vitamin is divided to two types. Water-soluble vitamins included thiamine, riboflavin, pyridoxine, pantothenic, niacin, biotin, folate. Next, myoinositol is also a component of membranes and it's involved in sending signals during several body processes. This is vitamin B12, choline, myoinositol, vitamin C. This is function. Choline function as a component of membranes, precursor of acetylcholine, a chemical for nerve transmission, provider for methyl group for chemical reactions. Next, vitamin C is involved in formation of connective tissue, bone matrix and wound repair. It also facilitates the absorption of iron from the intestine and helps prevent the peroxidation of the fat in tissue. Next, most water-soluble vitamins serve the echo enzymes in the body biochemical reactions. Enzymes are biological catalyzed. Most enzymes are proteins and they are unique for each biochemical reaction. Coenzyme then work with the become part of an enzyme. Next, the fat-soluble vitamins divided in 4 types: vitamin A, D, E, A. This is function. Fat-soluble vitamins are absorbed in the intestine along with fats in the diet. Unlike water-soluble vitamins, fat-soluble vitamins can be stored in the body tissues. Excessive amount of in the diet can cause a toxic condition which is called hypervitaminosis. Next, vitamin A is necessary for sight, proper growth, reproduction, resistance to infection and maintenance the body coverings. As many land animals, fish can use beta carotene as a vitamin A precursor. Vitamin A helps the body mobilize, transport, absorb and use calcium and phosphorus. It works with 2 hormones from an endocrine gland and parathyroid. Vitamin E is the name given to substance that act like alpha tocopherol. Vitamin E working with selenium protects cells against the adverse effect of oxidation. Vitamin K is required for the normal blood clotting process. Many animals can synthesize vitamin K in the intestine. Next, other dietary component. Water. All diets contain water. The water may be part of the feedstuffs come from the air or the added. The less water in a diet, the easier the storage and the handling. When moisture in diet exceeds 12%, the feed is more susceptible to spoilage. Some commercial diets contain high moisture levels because fish seems to prefer moisture feed. Next, fiber. Fiber refers to plant material such as cellulose, hemicellulose, lignin, pentose and other complex carbohydrates. These are indigestible and they don't play an important role in nutrition. Fiber adds bulk to a feed but increases the amount of fecal material produced. The goal is commercial aquaculture is to limit the diet, fiber content and the highly digestible feed. Next, antioxidant. Fish feeds containing high level of fat obtained use antioxidant. Oxidation of the fats affects the nutritional value of the fat and some vitamins. Synthetic vitamin E in diet usually less little antioxidant activity. Next, hormones. Researchers have evaluated the use of various natural and synthetic hormones of fish. The hormones included growth hormone, thyroid hormone, gonadotropin, prolactin, insulin, and various steroids like androgen and estrogens. Hormones are used for 2 purposes. First purpose, induced or synchronized spawning, and second purpose is sex reversal. Next, finally, is conclusion. Fish is a highly nutritive food rich in high quality protein, essential fatty acids included omega-3, vitamins such as D and B12, and important minerals like iodine, selenium, zinc. It comparison with depending on species, age, diet and habitat, but it generally included water, protein, fat and a small amount of carbohydrate. The presence of unsaturated fats and low saturated fat content makes fish a heart healthy dietary choice. Regular fish consumption supports brain function, cardiovascular health and overall well-being, making it a vital component of a balanced and nutritious diet. Thank you to all.